And we are live. Hey, what is up, everyone? Tyler back with another video. Whether you're watching this on Twitch while it happens live or after the fact on YouTube, it is an honor to have you hanging out with me this evening. We are going to change things up a little bit. First thing I'm going to do is adjust my camera. I feel like it's a little bit low. There we go. That looks better on my end, but we're going to change it up. Instead of hacking like we usually do, which I will continue to do that, I want to learn programming better. So I know Python somewhat. I know JavaScript somewhat. I wanted to learn C initially, and then someone on Discord said, hey, you should look into Rust and check out Rust. So I did a little bit of reading on Rust and thought, hey, let's learn Rust. Let's learn it together. I am nothing close to a programmer, nothing close to an expert, have never programmed in the Rust language, but it looks like they have some really good documentation, like official documentation that walks you through the basics and writing your first couple of programs. So I don't know how many videos I will make of this, of just kind of learning Rust series together, but let's dig in and see what we can learn. Let me go ahead and share my screen with you guys. What I am working with is Parrot OS. Parrot OS is a Linux distribution. I'm sure most of you watching this stream know that. It's very similar to Kali Linux. Both are good. And I'm just using Parrot because I've used Kali for a long time. I just want to change it up. And I've also heard that Parrot is good for programming. I'm sure Kali is as well, but we are going to use Parrot. I'm going to use Parrot. I would encourage you to use whatever you want. You can do these exercises in Windows as well. But if you do want to follow along with what I'm doing, I would encourage you to do it on Linux just because you'll be able to do exactly what I am doing. So boot up any Linux VM of your choice. And where we are going to begin, and I should ask you, I know there's a couple of you watching live on Twitch. If any of you have Twitch accounts and are able to chat, let me know if the audio sounds good. On my end, I can just see the audio levels. I'm not monitoring it at all, but it looks good on my end. But if it doesn't sound good to you guys, please let me know. I'm adjust the audio just a little bit, make it a little bit louder. Sounds good. Sweet. Good to hear that, Yogi Bear. But let's go ahead and dive into the documentation. So if you actually just go to Google, we'll find this ourselves. If you type in Rust programming book, I think that's all I typed, you can find their official programming thing. I did do, I think, chapter 1 just to get a feel for Rust, but I really haven't done anything else. So I'm going to read through this and we're going to learn it live together. So I would encourage you to follow along and see what we can learn about the Rust programming language. I like that it's open source and they're not going to yell at me for recording the stuff. That's always a plus. Can I close that? There we go. So this is just saying, here's the version of Rust, blah, 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 blah. Let's go to the first chapter. And I'll just read it in its entirety and see what we can learn. For those of you who might be new, anytime I do try hack me or hack the box, I like to read it in its entirety. I don't like to skim it because it's easy to miss things when we skim. So let's slow down. Our goal is not to finish through this quickly, but rather to try to learn something in the process. So let me zoom in just so you guys see it a little bit better. So let's just begin with the forward. It wasn't always so clear, but the Rust programming language is fundamentally about empowerment. No matter what kind of code you are writing now, Rust empowers you to reach farther, to program with confidence in a wider variety of domains than you did before. Sounds good to me. Take, for example, systems level work that deals with low-level details of memory management, data representation, and concurrency. Traditionally, this realm of programming is seen as arcane, accessible only to a select few who have devoted the necessary years learning to avoid its infinite pitfalls. And even those who practice it do so with caution, lest their code be open to exploits, crashes, or corruption. Cool. Rust breaks down these barriers by eliminating the old pitfalls and providing a friendly, polished set of tools to help you along the way. Programmers who need to dip down into lower level control can do so with Rust without taking on the customary risk of crashes or security holes, and without having to learn the fine points of fickle toolchain. Better yet, the language is designed to guide you naturally towards a reliable code that is efficient in terms of speed and memory usage. And for those of you watching on YouTube, I understand you guys can't see Twitch comments, so I will jump back and forth between the Twitch comments and the stream. Mike said, I missed a side note on when I tried installing Visual Studio and integrating GitHub. I felt so silly. All right, well, hopefully we'll see the side note. I haven't even got to that part, so we'll see if I fall into that as well. All right, programmers who are already working with low-level code, which is not me, can use Rust to raise their ambitions. For example, introducing parallelism in Rust is a relatively low-risk operation. The compiler will catch the classical mistakes for you. Anything that catches my mistakes is always a positive, and you can tackle more aggressive optimizations in your code with the confidence that you won't accidentally introduce crashes or vulnerabilities. But Rust isn't limited to low-level systems programming. It's expensive and ergonomic enough to make CLI apps, web servers, and many other kinds of code quite pleasant to write. You'll find simple examples both later in the book. Working with Rust allows you to build skills that transfer from one domain to another. You can learn Rust by writing a web app, then apply those same skills to target your Raspberry Pi. This book fully embraces the potential of Rust to empower its users. It's a friendly and approachable text intended to help you level up not just your knowledge of Rust, but also your reach and confidence as a programmer in general. So, dive in, get ready to learn, and welcome to the Rust community. Looking over at Twitch, Mike said it's a separate Python thing compared to this one, so sorry for the confusion. Oh, gotcha. No worries, man. It's good to have you learn Rust with me as well. I'm totally a new programmer. Like, I can do some things in Python. I can like modify scripts and I can write basic Python programmers, but I am nothing close to being a programmer. I can script on a good day with lots of Googling and maybe chat GPT. Okay. Introduction. Welcome to the Rust programming language, an introductory book about Rust. The Rust programming language helps you write faster, more reliable software, etc., etc. Let's jump down here. Who Rust is for. Rust is ideal for many people for a variety of reasons. Let's look at a few of the most important groups. Let's do it. Teams of developers. Rust is proving to be a productive tool for collaborating among large teams of developers with varying levels of systems programming knowledge. Low-level code is prone to various subtle bugs, which in most other languages can be caught only through extensive testing and careful code review by experienced developers. In Rust, the compiler plays a gatekeeper role by refusing to compile code with these elusive bugs, including concurrency bugs. I don't even know what concurrency bugs are, to be honest with you guys. By working alongside the compiler, the team can spend their time focusing on the program's logic rather than chasing down bugs. Rust also brings contemporary developer tools to the systems programming world. Cargo, the included dependency manager and build tool, makes adding, compiling, and managing dependencies painless and consistent across the Rust ecosystem. The Rust FMT language, I think format maybe? Formatting tool ensures a consistent coding style across developers. And the Rust language server powers integrated development environment, IDE integration, for code completion and inline error messages. By using these and other tools in the Rust ecosystem, developers can be productive while writing systems level code. Students, that's kind of us. Rust is for students and those who are interested in learning about systems concepts. Using Rust, many people have learned about topics like operating system development. The community is very welcoming and happy to answer student questions. Through efforts such as this book, the Rust teams want to make systems concepts more accessible to more people, especially those new to programming. Companies. Hundreds of companies, large and small, use Rust in production for a variety of tasks, including command line tools, web services, DevOps tooling, embedded devices, audio and video analysis, and transcoding, cryptocurrencies, bioinformatics, search engines, Internet of Things applications, machine learning, and even major parts of the Firefox web browser, which we are looking at this on. Open source developers. Rust is for people who want to build a Rust programming language, community, developer tools and libraries, and streamers who don't want to get dinged for copyright violation. We'd love to have you contribute to the Rust language. People who value speed and stability. Rust is for people who crave speed and stability in a language. By speed, we mean both how quickly Rust code can run and the speed at which Rust lets you write programs. The Rust compiler's checks ensure stability through feature additions and refactoring. This is in contrast to the brittle legacy code in languages without these checks, which developers are often afraid to modify. By striving for zero-cost abstractions, higher-level features that compile to lower-level code as fast as code written manually, Rust endeavors to make safe code be fast code as well. The Rust language hopes to support many other users as well. Those mentioned here are merely some of the biggest stakeholders. Overall, Rust's greatest ambition is to eliminate the trade-offs that programmers have accepted for decades by providing safety and productivity, speed and ergonomics. Give Rust a try and see if its choices work for you. Who this book is for. This book assumes that you've written code in another programming language, which I have, but doesn't make any assumptions about which one. Good. We've tried to make the material broadly accessible to those from a wide variety of programming backgrounds. We don't spend a lot of time talking about what programming is or how to think about it. If you're entirely new to program, you would be better served by reading a book that specifically provides an introduction to programming. How to use or stream this book. In general, this book assumes that you're reading it in sequence from front to back. Later chapters build on concepts in earlier chapters, and earlier chapters might not delve into details on a particular topic, but will revisit the topic in a later chapter. You'll find two kinds of chapters in this book: concept chapters and project chapters. In concept chapters, you'll learn about an aspect of Rust, and project chapters will build small programs together, applying what you've learned so far. I think, yeah, this is like, most books, they just go chapter by chapter. We're not going to read chapter by chapter. We'll learn it as we go. An important part of this process of learning Rust is learning how to read the error message the compiler displays. These will guide you toward working code. As such, we'll provide many examples that don't compile along with the error message the compiler will show you in each situation. Know that if you enter and run a random example and may not compile, make sure you read the surrounding text to see whether the example you're trying to run is meant to error. Ferris, everyone say hi, Ferris. Ferris will help you distinguish code that isn't meant to work. This code does not compile. This code panics. This code does not produce the desired behavior. Is this like a real debugging thing in Rust? That is definitely unique. In most situations, we'll lead you to the correct version of any code that doesn't compile. Source code, the source files are on GitHub. Okay. Getting started. Let's start our Rust journey together. This is day 1. There is a lot to learn, but every journey starts somewhere. So this is like we're going on an adventure. And here's how I think about programming. This might sound silly to you guys, but it makes sense in my head. I'm a fan of Harry Potter, right? And in Harry Potter, the better wizard you are, you know this language. And when you speak this language, things actually happen. That's what magic is in the Hogwarts universe. I kind of view programmers as wizards. They learn this kind of arcane language that not everybody knows. But when you speak this language, or rather when you write this language, you make things. What I'm recording with is OBS, something written in a programming language. What we are looking at is a website, something written in a programming language. So like programming languages are what make hackers and IT people wizards. You can cast spells, you can make stuff. That's how I pictured in my own head. So we are going to attempt to become Rust wizards, or at least like really newbie guys with wands who might be able to make something cool. Maybe. Let's learn how to be wizards. Installation. The first step is to install Rust. Now, this is the part I have done already, but I'm going to re-go through all the steps just so you guys do the steps as well. But I went up to this part just earlier today when I was looking at Rust, just so I understood how everything worked. But I'll redo it as well. The first step is to install Rust. We'll download Rust through RustUp, a command line tool for managing Rust versions and associated tools. You'll need an internet connection for the download, and if you're watching this stream, I'd assume you have an internet connection. If you prefer not to use RustUp, we're going to do whatever's easiest. The following steps install the latest stable version of the Rust compiler. Rust stability ensures that all the examples in the book that compile will continue to compile with newer Rust versions. The output might differ slightly between versions because Rust often improves error messages and warnings. In other words, any newer, stable version of Rust you install using these steps should work as expected with the content of this book. In this chapter... so it's just saying like, don't actually use a $sign. Okay, got it. Installing Rust on Linux or Mac OS. This is what I am using. So this is honestly super easy. I did this ahead of time thinking it'd be difficult, but it's not. Literally just copy that, open up a terminal. While we're opening a terminal, let's just go ahead and make a directory and we'll call it programming. And we'll CD over to programming. We'll make a directory and we will call it Rust like that. And Oculus or Paro, so Cyber Insight Candace casting spells. And Mike Farrow said they will use the sideways caret key instead of $sign. Yeah, I think if it's PowerShell, whatever, but you guys can ignore that, of course. We know how code looks. So we created our folders. We can CD into Rust if we want. I did not mean to do that. Okay. There we go. And now, literally copy and paste that command. I'm not going to do it. Well, I guess I can. I already installed Rust. And so I'm going to hit cancel, but if this is your first time, you'll of course hit 1, and it just installs in a few minutes. It's not a whole lot to that. For those of you joining live, I will just take a short break and hang out. You guys can look at me awkwardly, and I'll give you a chance to install Rust so that you can follow along and get a drink of water while yours installs. And for those of you in the chat, I am just curious, have any of you ever worked with Rust before? when I was reading about it online, a lot of people spoke really highly of it because it's similar to C. It can do some of the same things C can do, but it's made with safe coding practices instilled in it. So coding in Rust automatically reduces the attack surface of an application, is my understanding. Mike Firo said, I haven't. I'm starting Python right now. Awesome. Python is such a great language because it's easy to learn, but so incredibly powerful. And when I was doing the OSCP, most of the scripts and exploits are written in Python. And part of doing the OSCP is you have to modify exploits as you're going through the labs and as you're taking the test itself. So you need at least a basic understanding of Python so you can modify different exploits or write your own code a little bit. You don't have to be a Python programmer by any means, but Python's an incredible language to learn, and it teaches you kind of solid concepts behind programming. All right, I'm going to assume you guys have gotten it downloaded by now. The way to check, it's going to tell us in a second. But so this command, what up, S-Brand? Good to have you, my friend. I'm changing it up, and we're learning about Rust. The command downloads a script and starts the installation of the RustUp tool, which installs the latest stable version of Rust. You might be prompted for your password, blah, 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 blah. You'll get that message, Rust is installed now, great. Here's the Mac OS, here's Windows. We're not doing Windows. If you're doing Windows, I'll let you do that on your own. But here's how to check to see if it's installed. So it's just rust c -- version. So if we do rust c -- version, oh, is it not installed? Well, shoot, maybe I do need to install it. I could have swore I installed it. Oh well. Let's go ahead and proceed with installation. We'll install it as well. Mike Faro said, some of these free courses online didn't teach me about clear and control C to stop loops when I was learning. Well, I'm glad you learned. All right, to configure your current shell, and we'll just do that. We'll configure our current shell. Otherwise, it just needs to be echoed to our path variable, I'd assume, but we can do source. I think you can literally just copy it like this, cargo env. And now if we do rust c and version, there we go. We have Rust installed. You can see our version information there. Looking over at the chat, Cyber Insight said, Canada said, what is the difference between Python and Rust? Which one should be best to learn? Python by far is probably best to learn depending on your use case for it. If you want to do any type of offensive security, scripting, making tools, Python's going to be your best bet. Rust is more of a traditional language. It's very similar to C. You can probably do exploit writing in it. You can do a lot of things with Rust, but Rust is more of a traditional programming language. Python is a lot easier to learn. It teaches you the core concepts of programming. And if you're doing any exploits like online, if you're doing the OSCP, for example, you often need to modify Python exploits. So Python is a solid one to learn. I'm learning Rust, honestly, just for the fun of it. And so I can learn another programming language, but I'm not a programmer at all. I know a little bit of Python, a little bit of JavaScript. And honestly, that's about it. And I can do some bash scripting and a little bit of PowerShell. But I'm really not good at any of them, to be totally honest with you guys. But we got Rust installed. We can see at rust c -- version. In Windows, PowerShell. If you see this information, you've installed Rust successfully. If you don't see it, check that Rust is in your past system variable as follows. If that's all correct and Rust still isn't working, there are a number of places you can get help. Looking over at the chat, the guy said, hey, I want to offer you promotion. Sorry, bro, I don't need promotion. Appreciate you trying to offer that to me, but bye. I don't need any spam. Once Rust is installed, we can update. Woobies TV said he's a bot. Gotcha. To uninstall Rust, we're not going to do that. Local documentation. The installation of Rust also includes a local copy of the documentation so you can read it offline. Run rustup doc to open the local documentation in your browser. What does that even look like, I wonder? Oh, cool. Oh, so it just opens up the HTML. So then you could run the HTML yourself and read the website. That's pretty neat. Anytime a type or function is provided by the standard library and you're not sure what it does or how to use it, use the application programming interface documentation to find out. Hello world. Now that you've installed Rust, it is time to write your first Rust program. It's traditional when learning a new language to write a little program that prints the text hello world to the screen, so we'll do the same here. Note, This book assumes basic familiarity with the command line. Rust makes no specific demands about your editing or tooling or where your code lives, so if you prefer to use an integrated development environment instead of the command line, feel free to use your favorite IDE. Many IDEs now have some degree of Rust support. Check the IDE's documentation for details, and we'll probably just stick with command line type stuff for now. Create a project directory. You'll start by making a directory to store your Rust code. It doesn't matter to Rust where your code lives, but for the exercise and projects in this book, we suggest making a projects directory in your home directory and keeping all your projects there. Open a terminal and enter the following commands to make a projects directory and a directory for the Hello World project within the projects directory. Okay, so projects in Hello World, let's go ahead and do that. We already made our Rust thing, so we'll just make a directory called projects. We'll cd to projects, and we'll make a directory called Hello World. All right, we are there. Present working directory, perfect. Looking over at the Twitch chat, Mike Faro said, I can use Visual Studio. You can, my friend. Cyber Insight Canada said, you mentioned use GPT to write Rust programs. What does that look like? I actually haven't used it. I think I just made a joke about it. I haven't even tried to use Chat GPT to do that, but I know others have. And let's go ahead and keep learning. So that's Windows, writing and running a Rust program. Next, make a new source file and call it main.rs. Rust files always end with the rs extension. If you're using more than one word in your file name, the convention is to use an underscore to separate them. For example, use hello-world.rs rather than hello-world.rs, okay? Now open the main.js file you just created and enter the code in listing 1-1. So we're creating a main.js file. We could, I think, built into here, they use Pluma. Let's do Pluma, main.js. There we go. And can I know in Windows, you can just like, if I go like this and hit my Windows key, what does that do? Oh, sweet. Does it do it for this one too? Can I put this one to the side? Perfect. All right, we got our main.js. Now, we could just copy and paste this, but it's helpful to learn it. I think it's helpful to type it. So if we do fn, I'm guessing that means function. We're doing a main function, our curly braces, might be able to tab, maybe space, but print, ln maybe for line, and then that, and then hello. We'll say hello, hack smarter Twitch, like that. End it with the semicolon, colon like Python there. We'll go back here and close our curly braces. Now, if you're doing this in IDE, it'll do much of this for you. The one benefit of using a text editor while you're learning is it doesn't help you, right? You're forced to learn some of that stuff. So with fn main, all of that stuff looks good. Oh, I did JS, didn't I? What am I doing with my life? Yeah, you're right. It's supposed to be RS. I must have had JavaScript on my mind. Let's save that as main.rs. Good call. There we go. That looks a little bit neater. Okay, let's go ahead and save that. And let's see what it's going to tell us to do. Save the file. Go back to your terminal window in the projects Hello World directory. Enter the following commands. So we're going to compile the program because it's a compiled language. Can I throw this over there as well? Okay, well, we saved it. So if we ls, there is the main.rs, not JS. Don't copy what I did. So rustc main.rs. And it made a main, so now we should just be able to run it. Hello, hack smarter Twitch. Guys, we just wrote our first Rust program. That's exciting. Here's the Windows version of it if you're following along on Windows. Regardless of your OS, the string hello world or hello hack smarter Twitch should print to the terminal. If you don't see this output, refer back to the troubleshooting part of the installation section for ways to get help. If hello world did print, congratulations. You've officially written a Rust program. That makes you a Rust programmer. All right, we're done. We can learn a new language. We are a Rust programmer. We might as well learn like C now. Anatomy of a Rust program. Let's review this Hello World program in detail. Here's the first piece of the puzzle. fn main. These lines define a function named main, which is kind of what we assumed. The main function is special. It is always the first code that runs in every executable Rust program. Here, the first line declares a function named main that has no parameters and returns nothing. If there were parameters, it would go inside the parentheses right there. That's kind of like Python in some ways when you define. The function body is wrapped in curly braces, as we can see that. Rust requires curly brackets around all function bodies. It's good style to place the opening curly bracket on the same line as the function declaration, adding one space between. Note, if you want to stick to a standard style across Rust projects, you can use an automatic formatter tool called Rust FMT to format your code in a particular style. Okay? The body of the main function holds the following code, and we can even, if we cat main.rs, right, we can see our code there. So here's the body of the main function. This line does all the work in this little program. It prints text to the screen. There are 4 important details to notice here. First, Rust styles an indent with 4 spaces, not a tab. Whoops, I tabbed it. Second, print line calls a Rust macro. If it had called a function instead, it would be entered as print line without the exclamation mark. We'll discuss Rust macros in more detail in Chapter 19. For now, you just need to know that using an exclamation mark means that you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. Got it. Third, you see the hello world string. We pass this string as an argument to print line, and the string is printed to the screen. Fourth, we end the line with a semicolon, which indicates, and we can see that there, which indicates that this expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. Looking over at the chat, Mike said, add that to our resume. Yep, so I can add to my LinkedIn. I am now a Rust programmer. Awesome. And Cyber Insight Canada said, is your example main.rs compiled or interpreted? This is compiled. We are actually compiling it with Rust and then running it. And you can notice a difference. We have 2 files. There's our code and there's our compiled program, main. And that we're going to talk about that. Looks like compiling and running are separate steps. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the Rust C command and passing it the name of your source file like this, which is what we did. If you have a C or C++ background, you'll notice that this is similar to GCC or Clang. If you do Kali exploit OSCP type stuff, we use GCC a lot to compile C exploits. After compiling successfully, Rust outputs a binary executable. That's our main. On Linux, Mac OS, and PowerShell, we're going to kind of skip through that. On Linux and Mac OS, you'll see 2 files. With PowerShell on Windows, you'll see the same 3 files that you would see using CMD. With CMD on Windows, blah, 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 blah. This shows the source code with the RS extension, a file containing debugging. We're skimming Windows because we're not doing Windows. If your main.rs is your hello world program, this line prints hello world to your terminal. If you're more familiar with a dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is an ahead-of-time compiled language, meaning you can compile a program and give the executable to someone else, and they can run it even without having Rust installed. Cool. If you give someone a .rb, .py, or .js file, they need to have Ruby, Python, or JavaScript implementation installed respectively. But in those languages, you only need one command to compile and run your program. Everything is a trade-off in language design. Just compiling with Rust C is fine for simple programs, but as your project grows, you'll want to manage all the options and make it easy to share your code. Next, we'll introduce you to the Cargo tool, which will help you write real-world Rust programs. All right. Hello, Cargo. Cargo is Rust's build system and package manager. Most Rusticians, am I saying that right? Use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. The simplest Rust programs, like the one we've written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. All right. Cargo comes installed with Rust if you used the official installers discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by entering the following in your terminal. And we have it. Cool. If you see a version number, you have it. If you see an error, you don't have it. Figure it out. Creating a project with Cargo. Let's back out to our project folder. Let's create a new project using Cargo. and look at how it differs from our original Hello World project. Navigate back to your project's directory, or whatever you decided to store your code. Then on any OS, run the following. So cargo, new, hello, cargo. Okay. What's in here? Interesting. The first command creates a new directory and project called hello cargo. We've named our project hello cargo, and cargo creates its files in a directory of the same name. Go into the hello cargo directory and list all the files, which we did that. You'll see that cargo has generated 2 files in one directory for us. Our cargo.toml file and a source directory with a main.rs file inside. So if we list src, there it is. It has also initialized a new Git repository along with the git ignore file. Really? Git files won't be generated if you run cargo new within an existing Git repository. You can override this behavior by using cargo new vcs equals git. Note, Git is a common version control system. You can change cargo new to use a different version control system or no version control system by using the VCS flag. Run cargo new help to see the available options. Do I have Git on here? Okay, I do. Sweet. Open cargo.toml in your text editor of choice. It should look similar to the code. So let's do that. If we use Pluma again and open cargo, and if we just throw this over to the side there, it should look similar to this. So we have our name, our version, our edition, and dependencies, if we had dependencies, I suppose. The file is in the toml, Tom's obvious minimal language format, thanks Tom, which is cargo's configuration format. The first line, package, is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 3 lines set the configuration information cargo needs to compile your program: the name, the version, and the edition of Rust that we'll use. We'll talk about the edition key in Appendix E. The last line, dependencies, is a start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in Chapter 2, so we'll use this dependency section then. Now open source main rs and take a look. Okay, well let's go ahead and do that. And there's that, so Pluma main.rs. And we want it on the other screen, there we go. And the way I'm doing that, I guess I should tell you guys, I'm hitting the Windows key on my keyboard and hitting my arrow key in case you don't know that trick, so you can kind of snap to different screens. I actually have 4 monitors in front of me, but of course you guys can only see 1 monitor, so I'm forced to work on my 1 monitor. All right, now, so it already made this for us. We have our function, our main, our print line, our macro we're calling, and hello world. Cargo has generated a hello world program for you, just like the one we wrote in listing 1-1. So far, the differences between our project and the project, sorry, I had a text that distracted me, and the project cargo generated are that cargo placed the code in the source directory, and we have a cargo.toml configuration file in the top directory. Cargo expects your source files to live inside the source directory. Makes sense? The top level project directory is just for README files, license information, configuration files, and anything else not related to your code. Using cargo helps you organize your projects. There's a place for everything, and everything is in its place. If you started a project that doesn't use cargo, as we did with the Hello World project, you can convert it to a project that does use cargo. Move the project code into the source directory and create an appropriate cargo.toml file. All right, that makes sense. Building and running a cargo project. Now, let's look at what's different when we build and run the Hello World program with cargo. From your Hello Cargo directory, all right, so let's close this out. Build your project by entering the following command. So from the Hello Cargo directory. So let's CD back to that. And we are going to just run cargo build, it looks like. Cargo build. All right, this command creates an executable file in target debug hello cargo or target debug hello cargo.exe on Windows rather than in your current directory. Because a default build is a debug build, cargo puts the binary in a directory named debug. You can run the executable with this command. Okay, so let's see, ls target like that, debug and hello Hello world. Cool. And I'm going to turn my desktop audio down so you guys don't hear Parrot beep at you if I type something wrong, so it's not super loud. If all goes well, hello world should print to the terminal. Running cargo build for the first time also causes cargo to create a new file at the top level, cargo.lock. cd hello cargo. Oh, cargo.lock. If all goes well, blah, blah. This file keeps track of the exact versions of dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. Let's look at it. Automatically generated. It's not intended for manual editing. Okay, neat. We just built a project with cargo build and ran it with target debug hello cargo, but we can also use cargo run to compile the code and then run the resultant executable all in one command. Can we? So if we just type cargo run, oh, that's cool. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary, so most developers use cargo run. Water break. Notice, or jumping over to chat, Cyber Insight Canada said, can you decompile a compiled Rust binary? I'd assume you can. Yeah. I mean, I haven't done it, but I assume you'd be able to. Notice at this time, we didn't see output indicating that cargo was compiling hello cargo. Cargo figured out that the files hadn't changed, so it didn't rebuild, but just ran the binary. If you had modified your source code, cargo would have rebuilt the project before running it, and you would have seen this output. And I mean, we can do that just for learning. Let's go ahead and do that. So if we go over to source, ls, and if we do pluma main like that, and we'll just add another exclamation mark like that, Control S to save it, we'll close that out, and if we cd and we do cargo run, we can see it compiles it and then it runs it. Very cool. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. All right, let's clear our terminal. Cargo check. Sweet. Why would you not want an executable? Often, cargo check is much faster than cargo build. I'd imagine you imagine a full program, right? Because it skips a step of producing executable. If you're continually checking your work or writing the code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many Rusticians run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Let's recap what we learned so far about cargo. We can create a project using cargo new. We can build a project using cargo build. We can build and run a project in one step using cargo run. We can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build in the same directory as our code, cargo stores it in a target/debug directory. An additional advantage of using cargo is that the commands are the same no matter which OS you're working on. So at this point, we'll no longer provide specific instructions for Linux and Mac OS versus Windows. That's actually really cool. Building for release. When your project is finally ready for release, you can use cargo build -- release to compile it with optimizations. This command will create an executable in target release instead of target debug. The optimization makes your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles, one for dev and when you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build -- release and benchmark with the executable in target/release. I mean, let's just do that, should we? So cargo build release, let's just see the process. And if we ls and if we cd target, we have release. Yeah, so if we go to release and we have our build. Oh, so we have examples. This is cool. So if we had examples, I bet examples is empty. But if you were putting this on GitHub, right, you'd be able to fill that in with that information. And now if we run hello cargo, we have hello world. That is pretty neat. Cargo as convention. With simple projects, cargo doesn't provide a lot of value over just using Rust-C, but it will prove its worth as your programs become more intricate. Once programs grow to multiple files or need a dependency, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple and now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using git, change to the project's directory, and build. So git clone cd cargo build. Should we try that? Let's go to isn't Rust scan something? It does scan in-map type stuff. We could try to compile this just for practice. Let's just read through Rust scan. I've never actually used Rust scan. I always just use in-map. Scan 65,000 ports in 3 seconds. That's cool. The users you expect automatically pipes ports into in-map. Why use Rust scan? Where's the install, I wonder? Usage. We have 2 usage guides, things you may want to do. So can I just git clone this and do cargo build, do you guys think? I see cargo.toml and cargo.lock. Let's try that. Let's just see what happens. So if we grab the code there, and if I don't really want to do it here, if we cd out, we'll just cd out to Rust there, and we'll do git clone like that. Curious if this works. So git clone, and we'll cd, whoops, I don't know what was happening there. cd Rust scan like that. And can we just do cargo build? Yeah. So I added my own practice and we are compiling a program. We'll let that do its thing and we'll keep reading. For more information about Cargo, check out its documentation. I need another drink. Summary. You're already off to a great start on your Rust journey. In this chapter, you've learned how to install the latest stable version of Rust using Rust Up, update to a newer Rust version, open locally installed documentation, write and run a Hello program using Rust C directly, create and run a new project using the conventions of Cargo, and apparently compile Rust scan. This is a great time to build a more substantial program to get used to reading and writing Rust code. So, in Chapter 2, we'll build a guessing game program. If you'd rather start by learning how common programming concepts work in Rust, see Chapter 3 and then return to Chapter 2. Let's jump over here. I will jump over to Twitch chat. Mike Firo said language is neat. I agree. Sean Zepp said I'm learning Python slowly right now as I juggle school and work. What made you go for Rust? I know nothing about it. Honestly, Sean, that's a really good question. I'm okay at Python. I am not good at Python. I'm okay at it. Python's a really powerful language. I originally was going to learn C. Since most OSs like Linux, Windows are written in C. And a lot of what I noticed when I was doing the OSCP is a lot of the exploits you were doing, you had to compile with GCC and they're written in C. So I thought, hey, if I ever want to do like exploit development, C would be a good language to learn. And then just in the Work Smarter Discord, which if you guys aren't a part of it, you should join it. Anyone who is part of Work Smarter, if you can drop a link in the chat, I would appreciate it. Otherwise, if you're watching this on YouTube, check it out in the description below. But someone said, hey, have you considered Rust? And I knew of Rust scan. That's about it. I haven't read much about Rust and just did some Googling about the Rust programming language. And it seemed really neat, the things that you could do with Rust. And then what really sold me was their documentation. The book that we're going through right now is released officially from Rust. The challenge I had is whatever language I wanted to learn, I wanted to live stream it. I wanted to invite you guys on this journey with me, and hopefully we could learn something together. I'm obviously not an expert. I'm learning as I go. But what I liked about Rust is they have this open source book that I can read. Other books, like for C and other languages, you have to purchase. And if I were to take that book as an ebook and read it on Twitch and YouTube would both get mad at me. But Rust is all open source, and no one's going to get mad at me for working my way through it on stream. So, long answer short. Or short answer long. I don't know. Programming a guessing game. Let's jump into Rust by working through a hands-on project together. Let's do it. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match methods, associated functions, external crates, and more. In the following chapters, we'll explore these ideas in more detail. In this chapter, you'll just practice the fundamentals. We will implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. It will then prompt the player, that is us, to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. So setting up a new project, RustScan is still doing its thing. Can I just open a tab on here? Is everything still good? Oh, is it not in my path? 1 second. Trying to think of the best way to do that. If I locate, all right, I'm gonna figure out how to add it to my path real quick. It must just be in that one terminal window. Installation, export path, source path. I'm reading on my other monitor if you guys wonder what I'm looking at. Also, you can add the following line to your bash profile. So let's go ahead and add this line to our bash profile. Export path equals, and you can follow along if you had the same issue. It might just be limited to me. .cargo bin path. Okay. There we go. Fix that problem. Get Twitch back open. Oh, my computer is being slow. Maybe it's with Rust. Okay, well, I might stop our Rust scanner. I think it's slowing down my VM. Yeah, it's using all my processor. I mean, it's almost done. We'll give it a chance to hit 199. But it worked, right? We compiled the Rust scan by just looking at the documentation for Rust. I actually didn't think that was going to work. And I'll have to mess with the Rust scan next time I do a box or a pen test. A real pen test. We'll see. 9 more. That means a water break. We'll probably stream for like another 20 minutes maybe. That sounds good to you guys. Maybe we'll try to work our way through this chapter, and then we'll break off for next time. Building Rust scan. Hey, it's done. So, can I just... I don't know how to call it. Probably have to add that to my path as well, one would think. Oh well, let's go back to learning our Rust language. So setting up a new project. To set up a new project, go to the projects directory. So let's do that. You create in chapter 1 and make a new project using cargo like so. So cargo new guessing game. And it created, let's cd to our guessing game. There we go. There's our guessing game. There's our cargo. We're going to go to source, I'm sure. The first command, cargo new, takes the name of the project. Guessing game is the first argument. The second command changes to the new projects directory. Look at the generated cargo file. So we can look at that. We've already kind of looked this over. Not a whole lot to see here. And then if we go to our file name, cd source, ls, cat main, and there's our hello world program. Now let's compile this hello world program and run it in the same step using the cargo run command. So we can do that, I suppose, just for learning and redoing what we already learned. So if we do cargo run, it should give us hello world, and there it is. The run command comes in handy. We need to rapidly iterate on a project, as we'll do in this game, quickly testing each iteration before moving on to the next one. Reopen the source file. So we'll go here, Pluma main, like that, and we'll bring that over to the other side of the screen. And let me see if I can make Pluma a little bit bigger for you guys. Would it be preferences maybe? Preferences, editor, font and colors. Let's go here, and let's just make this a little bit bigger so it's easier for those of you watching online. There we go. Hopefully you can see it a little bit better now. Processing a guess. The first part of the guessing game program will ask for user input. Process that input and check that the input is in the expected form. To start, we'll allow the player to input a guess. Enter the code and listen 2.1 into source.main.js. And let's see if we can understand this while we enter it, right? So we have our fn main. It looks like we have to add this use thing. I'm guessing this is a library, a dependency, a crate, whatever they call it. So let's add our crate. I don't even know if that's the right terminology, but that's my guess up there. And then we have our fn main, and we're going to change our print line, of course, here. And we'll call that guess the number. And we'll do a space, print line again. Please input your guess like that. And then let mut guess equals, so this must be receiving the user input. We know it's going to be a string, new. I'm guessing that is the understanding of that. And we'll jump down a little bit. IO, I'm guessing we're making a call to our dependency or library up above. stdin, like that. And then 4 spaces, 1, 2, 3, 4. They said that's a proper way to do it. Dot read line mut guess, like that. And like I said before, you can copy and paste this, but you'll learn a lot more typing it out and working your way through it as you go. Failed to read line, like that. And we'll do another print statement. So we'll go back here, print line, you guessed, and then we're importing that, our guess variable in there, like that, and like that. So we have our main function. We're asking the user to guess the number, and then we're printing another line saying, please input your guess. We're grabbing the user's input and we're saving it. So let mut, or whatever this is establishing a variable called guess. It's a string. It's a new variable that we're establishing. We're going to read the line. We're going to read the line of the user's guess. And if it doesn't work, it's going to say it failed to read the line, I suppose, if they input something weird. And then it's going to say, you guess, and here's our guess. That's my understanding reading through it. Let's see how close we are. This code contains a lot of information, so let's go over it line by line. To obtain user input and then print the result as output, we need to bring the IO input-output library into scope. So I was correct on that part. The IO library comes from the standard library known as std, so standard. Makes sense? By default, Rust has a set of items defined in the standard library that it brings into the scope of every program. This set is called the prelude, and you can see everything in it in the standard library documentation. If a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with a use statement. Using the standard IO library provides you with a number of useful features, including the ability to accept user input. As you saw in Chapter 1, the main function is the entry point into the program, which we can see there. The fn syntax declares a new function right there. The parentheses indicates there are no parameters. If they were, they'd be in there. And the curly brackets start the body of the function, of course, ends it. As you also learned in Chapter 1, print line is a macro that prints a string to the screen, which we got that part down. The code is printing a prompt stating what the game is and requesting input from the user. Cool, makes sense so far. Storing values with variables. Next, we'll create a variable to store the user input like this. Let mut guess string new. We had that part right. Now the program is getting interesting. There's a lot going on in this little line. We'll use the let statement to create the variable. Here's another example. Let apples equal 5. This line creates a new variable named apples and binds it to the value of 5. In Rust, variables are immutable by default, meaning once we give the variable a value, the value will not change. Looking at Mike, he said, I must go. Friend's cat wants attention. All right, Mike, thank you for hanging out, my friend. Enjoy hanging out with the cat. Meaning once we give the variable a value, the value won't change. We'll be discussing this concept in detail in the variables and mutability section in Chapter 3. To make a variable mutable, we add mute. Oh, okay, that's what it is. Not mut, mute, before the variable name. So that's so we can change the variable. Let apples equals 5 is immutable. Let mute bananas equal 5 is mutable, meaning we can change it. The /s syntax starts a comment that continues until the end of the line. Rust ignores everything in comments. We'll discuss the comments in detail. So we can say mut is pronounced mute, right? Mutable. There we added a comment just for practice there. Returning to the guessing game, you now know that let mute guess will introduce a mutable variable named guess. The equal sign tells Rust we want to bind something to that variable. Now I lost where I was reading because I glanced over there. On the right of the equal sign is a value that guess is bound to, which is a result of calling string new, a function that returns a new instance of a string. String is a string type provided by the standard library that is growable, UTF-8 encoded bit of text. The ... syntax in the new line indicates that new is an associated function of the string type. Okay, so this is a function modifying string or associated function of the string type. Got it. An associated function is a function that's implemented on a type, in this case, string. This new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. Got it. In full, the let mute guess equals string new line has created a mutable variable that is currently bound to a new empty instance of a string. Got it. Receiving user input. Recall that we included the input-output functionality, that's up there, from the standard library with use stdio on the first line of the program. Now we'll call the stdin function from the IO module, which will allow us to handle user input. So input, output, stdin, we're calling that from that library. Read line, mutable, guess, so we're reading that line, and expect fail to read line. If we hadn't imported the IO library with the use stdio at the beginning of the program, we could still use the function by writing this function call as stdio stdin. The stdin function returns an instance of that, which is a type that represents a handle to the standard input for your terminal. Next, the line read line mute guess calls the read line method, which we can see that right there, on the standard input handle to get input from the user. We're also passing immutable guess as the argument to readline to tell it what string to store the user input in. The full job of readline is to take whatever the user types into standard input and append that into a string without overwriting its contents. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change the string's content. The ampersand indicates that this argument is a reference. Okay, so right there, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Hence, you need to write mute guess rather than guess to make it mutable. Makes sense? Chapter 4 will explain more. A lot of reading. Learning good stuff, though. Handling potential failure with result. We're still working on this line of code. We're now discussing a third line of text, but note that it's still part of a single logical line of code. The next part is this method. Expect failed to read line. We could have written this code as IO stdin, read line, mute guess, expect failed to read line, drink of water. However, one long line is difficult to read, so it's best to divide it. It's often wise to introduce a new line and other white space to help break up long lines when you call a method with the method name syntax. Now, let's discuss what this line does. As mentioned earlier, read line puts whatever the user enters into the string we pass to it, but also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We'll call each possible state a variant. Okay, just reading through this, make sure I understand it. Chapter 6, we'll cover it in more detail. Got it? The purpose is to encode error handling information. Results variants are OK and error, so 0 and 1 basically. The OK variant indicates the operation was successful, and inside OK is the successfully generated value. The error variant means the operation failed. An error contains information about how or why the operation failed, which is probably that. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. If the instance of result is an error value, expect will cause the program to crash and display the message that you pass as an argument to expect. If the readline method returns an error, it would likely be the result of an error coming from the underlying OS. If this instance of result is an OK value, expect will take the return value that OK is holding and return just that value to you so you can use it. In this case, that value is the number of bytes in the user's input. If you don't call expect, the program will compile, but you'll get a warning. Unused result that must be used. So if we ever see this error, we know that it's likely we don't have this essentially thing to catch errors, expect. Rust warns that you haven't used a result value returned from read line, indicating that the program hasn't handled the possible error. The right way to suppress the warning is to actually write error handling code, but in our case, we just want to crash this program when a problem occurs, so we can use expect. You'll learn about recovering from errors in Chapter 9. Got it. Printing values with print line placeholders. Aside from the closing curly bracket, there's only one more line to discuss in this code so far, and that's right here. You guessed, guess. This line prints a string that now contains the user's input. The curly bracket set of curly brackets is a placeholder. Think of those as little crab printers that hold a value in place. When printing the value of a variable, the variable name can go inside the curly brackets. When printing the result of evaluating an expression, place empty curly brackets in the format string, then follow the format string with a comma-separated list of expressions to print in each empty curly bracket placeholder in the same order. Printing a variable and the result of an expression in one call to print line would look like this. Let x equal 5, let y equal 10. So print line, x, in parentheses, x equals our placeholder of x, so x equals 5, and y plus 2 equals, curly brackets, y plus 2. This code would print x equals 5, and y plus 2 equals 12, 10. Okay, I see, because we're doing our curly brackets here, and then defining y out here, which is going to be 10 plus 2. All right, x equals 5, and y plus 2 equals, okay. Testing the first part. Let's test the first part of the guessing game. Run it using cargo run. Okay. Well, let's go ahead and make sure we save this. And I suppose if we just open our terminal, we can go to our other window here and cd out, cd to projects, and cd to guessing game. And now we can do cargo run. Please input your guess. You guessed 1337. At this point, the first part of the game is done. We're getting input from the keyboard and then printing it. Good job. That means a water break. Generating a secret number. Next, we need to generate a secret number that the user will try to guess. And let's go ahead and pull up our file here. Blah, blah, blah. The secret number should be different every time so the game is fun to play more than once. We'll use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include random number functionality in the standard library. However, the Rust team does provide a ran create with said functionality. All right. Remember that crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The ran crate is a library crate, which contains code that is intended to be used in other programs and can't be executed on its own. So we're taking a crate of stuff. Cargo's coordination of external crates is where cargo really shines. Before we can write code that uses ran, we need to modify the cargo.toml file to include the ran crate as a dependency. Okay. Open that file now and add the following line to the bottom beneath the dependency section header that Cargo created for you. Be sure to specify ran exactly as we have here. With this version number, the code examples in this tutorial may not work. So we could just do nano cargo.toml. There's nothing there. Oh, I did it wrong. Hold up. Nano cargo.toml, case sensitivity matters. And if we go down to our dependencies here, we'll do ran equals 0.8.5 like that. Control X to save. And just make sure we did that right. And there it is. So we have it. Perfect. In the cargo toml file, everything that follows a header is part of that section. So we can still cat it out so we can see ours. .toml. Oh, .toml. Thank you. Everything that follows a header is part of that section that continues until another section starts. In dependencies, you tell cargo which external crates your project depends on and which versions of those crates you require. In this case, we specify the RAN crate with the semantic version specifier 0.8.5. Cargo understands semantic versioning, sometimes called semver, which is a standard for writing version numbers. The specifier 0.8.5 is actually shorthand for caret key 0.8.5, which means any version that is at least 0.8.5 but below 0.9.0. Got it. Cargo considers these versions to have public APIs compatible with version 0.8.5, and this specification ensures you'll get the latest patch release that will still compile with the code in this chapter. Any version 9.0 or greater is not guaranteed to have the same API as what the following examples use. Now, without changing any of the code, let's build a project as shown in listing 2-2. All right, cargo build. And look at that, we're downloading all those crates. That's actually really cool. You may see different version numbers, but they'll all be compatible with the code thanks to semver, and different lines depending on the OS, and the lines may be in different order. Well, it did it. When we include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of data from crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed RAN as a dependency, Cargo also grabbed other crates that RAN depends on to work. After downloading the crates, Rust compiles them and then compiles their project with the dependencies available. If you immediately run cargo build again without making any changes, you won't get any output aside from the finish line. Cargo knows it's already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply says peace out. If you open source.main.js, make a trivial change, and save it, you'll see 2 lines of output. We already did that, so I'm not going to do it again. These lines show that Cargo only updates the build with, enter. With your tiny change, your dependencies haven't changed, so Cargo knows it can reuse what is already downloaded and compiled for those. Ensuring reproducible builds with the cargo.lock file. Cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. Cargo will use only the versions of the dependencies you specified until you indicate otherwise. For example, say that next week's version of 0.8.6 of the RAN crate comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates a cargo.lock file the first time you run cargo build, so we now have this in the guessing game directory. Let's take a look at it. Cat cargo.lock. Oh, yep, and there's all of our packages and our version information. When you build a project for the first time, Cargo figures out all the versions of the dependencies that fit the criteria and then writes them to the cargo.lock file. When you build your project in the future, Cargo will see that the cargo.lock file exists and will use the version specified there rather than doing all the work of figuring out versions again. This lets you have a reproducible build automatically. In other words, your project will remain at 0.8.5 until you explicitly upgrade, thanks to the cargo.lock file. Because a cargo.lock file is important for reproducible builds, it's often checked into source control with the rest of the code in your project. Updating a crate to get to a new version. When you do want to update a crate, Cargo provides the command update, which will ignore the cargo.lock file and figure out the latest version that fit your specifications in cargo.toml. Cargo will then write those versions to the cargo.lock file. Otherwise, by default, Cargo will only look for versions greater than 0.8.5 and less than 0.9.0. If the RAN crate has released the 2 new versions, 0.8.6 and 9.0, you would see the following if you ran Cargo update. Okay. Cargo ignores the 9.0 release. At this point, you would also notice a change in your cargo.lock file, knowing that the version of the RAN crate you are now using is 0.8.6. To use RAN version 9.0 or any version of the 9x, you'd have to update the cargo.toml file to look like this instead, which we're not going to do. The next time you run cargo build, Cargo will update the registry of crates available and reevaluate your RAN requirements according to the new version you have specified. There's a lot more to say about cargo and its ecosystem, which we'll discuss in chapter 14, but for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so Rustaceans are able to write smaller projects that are assembled from a number of packages. All right, let's generate a random number. Let's start using rand to generate a random number to guess. The next step is to update that as shown in that picture. So let's go ahead and do this. And let's try to understand the code as we write it. So we're adding our other library, this random library that we just added, if I could type, added as a dependency. We'll add that to the top. And we're specifying a secret number variable. So let's jump down here. Let secret number equal, we're pulling from the rand library, thread range, I think maybe. Generate range 1 to 100. So we're generating a range of numbers between 1 and 100. And it looks like we're going to print, just for code checking, of course, print line, our little macro key, the secret number is, and then we're going to use our curly brackets to grab that secret number like that. And close our parentheses and do our semicolon. Perfect. Please input your guess. We got that. Let mutable guess. We're making a guess that is mutable because the user can update it. Read line. That all looks right. Failed to read line, and you guess. All right. That's everything that we needed to do. We can open our terminal back up. Well, actually, they're going to walk us through it, so we'll keep this open. First, we add the use rand range, maybe random range. The RNG trait defines methods that random number generators implement, and this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail. Next, we're adding 2 lines in the middle. In the first line, we call the rand thread RNG function that gives us the particular random number thread, which is right here is what it's referring to, that we're going to use, one that's local to the current thread of execution and is seeded by the OS. Then we call the gen range method on the random number generator. This method is defined by the RNG trait that we brought into scope with the use rand range statement. The gen range method takes a range expression as an argument and generates a random number in the range. The kind of range expression we're using here takes the form start ... end and is inclusive on the lower and upper bounds. So we need to specify 1 to 100 to request a number between 1 and 100. That makes sense. Note, you won't just know which traits to use and which methods and functions to call from a crate, so each crate has documentation with instructions for using it. Another neat feature of Cargo is that running the cargo doc open command will build documentation provided by all your dependencies locally and open it in your browser. That's very cool. If you're interested in other functionality in the run create, for example, run cargo doc open and click ran in the sidebar on the left. The second new line prints the secret number. That's right here. This is useful while we're developing the program to be able to test it, but we'll delete it from the final version. It's not much of a game if the program prints the answer as soon as it starts. Try running the program a few times. So let's go ahead and do it. I don't know if I save this. And we'll go here and we'll do cargo run. Oh, look, I have an error. That's good. So I forgot a semicolon on line 7, it would appear. Let's check. I did. That was actually good learning on stream. We can see their error messages. Now, if we do it again, now it works. The secret number is 19. We'll type 19, and you guess 19. Perfect. Callie Mac said, go Tyler, gotta hit the grocery store. Want to see what you're learning now. Good stuff. Thanks, man. Thanks for hanging out with me. Have fun at the grocery store. You should get different random numbers. So let's run it again. And we did. That time it's 80. We'll say that. That time it is 64. So it is for sure working. We made a random number generator, comparing the guess to the secret number. Now that we have user input and a random number, we can compare them. That step is shown in listing 2-4. Note that this code won't compile just yet, as we will explain. All right, well, let's go ahead and pull this up. So it's snipping that, you guess. Okay, I see. So we need to add this other library, use from the standard library, CMP. I'm guessing that means compare and ordering like that. And we have our main. We snip down to print you guess. So we're going to start typing here, and let's see if we can understand this. We're going to match from our guess.cmp, our library there, our and secret number. And remember, our and secret number is immutable. We don't want it to change, at least not right away, at least not when we first guess. And we'll add that. And 4 spaces, 1, 2, 3, 4, they said is a proper way to do it. So ordering less, and then we have this arrow thing, print line too small, like that. Ordering greater, make our arrow again, and print line too big. Oh, we need to add our commas. Almost missed on that one. I notice we're not ending this one with the semicolon because they're all part of one bunch that go together. Ordering equal, make our little arrow key thing, print line like that. You win. And of course, 1, 2, 3, 4, we need to close our curly bracket that we opened. We'll save that. First, we add another use statement, which we did up there, bringing a type called standard compare ordering into scope from the standard library. The ordering type is another enum and has the variants less, greater, and equal. Less, greater, and equal. These are the 3 outcomes that are possible when you compare 2 values. Then we add 5 new lines at the bottom that use the ordering type. The CMP method compares 2 values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it's comparing guess. Okay, so we're comparing guess. Oh, I see. So guess, CMP for compare, secret number. So we're setting our secret number variable up there. We're setting our guess variable right there based on user input, and the CMP is comparing both of them. Got it. Then it returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression to decide what to do next based on which variant of ordering was returned from the call to CMP with the values and guess and secret number. A match expression is made up of arms. An arm consists of a pattern to match against, and the code that should be run if the value given to match fits that arm's pattern. Rust takes the value given to match and looks through each arm's pattern in turn. Patterns and the match construct are powerful Rust features. They let you express a variety of situations your code might encounter and then make sure you handle them all. These features will be covered in detail in Chapter 6 and 18 respectively. Let's walk through an example with the match expression we use here. Say that the user has guessed 50 and the randomly generated secret number this time is 38. When the code compares 50 to 38, the CMP method will return ordering greater right there because 50 is greater than 38. The match expression gets the ordering greater value and starts checking each arm's pattern. It looks at the first arm's pattern, ordering less, and sees that the value ordering greater does not match ordering less, so it ignores the code in the arm and moves to the next arm. The next arm's pattern is ordering greater, which does match ordering greater. The associated code in that arm will execute and print too big to the screen. The match expression ends after the first successful match, so it won't look at the last arm in this scenario. However, the code won't compile, but let's try it. Let's do it. And let's see if we can read the error message before they tell us what it means. So, cargo, run. Okay. Ooh, mismatch types. So we have a mismatch type on line 22. On the secret number, it expected the structure string, but it found an integer. Integer, I should say, not integer, integer. Arguments to this function are correct. Note expected reference would be string, but it found the reference integer. Associated function defined here. For more information about the error, try Rusty explain that. Cannot compile guessing game due to previous error. And let's just try that. I mean, we can obviously see what the error is, but what if we didn't? Let's see how helpful this is. Rusty explain E0308. Expected type did not match. Erroneous type examples. This occurs when an expression was used in play, so it gives us some good information there. Whoops. Okay, so let's see what they have to tell us. Oh, they did cargo build first. I don't think we need to do... Oh, yeah, we do need to do cargo build, don't we? Because we added a new library. Let's do that as well. And that's where it fills. We try to build it, and it says, hey, sorry, it doesn't work. The core of the error states that there are mismatched types. Rust has a strong static type system. However, it also has type inference. When we wrote let mutable guess equals string new, Rust was able to infer that guess should be a string and didn't make us write the type. The secret number, on the other hand, is a number type. A few of Rust's number types can have a value between 1 and 100. I32, a 32-bit number, U32, an unsigned 32-bit number, I64, a 64-bit number, as well as others. Unless otherwise specified, Rust defaults to an I32, which is the type of secret number, unless you add type information elsewhere that would cause Rust to infer a different numerical type. The reason for the error is that Rust cannot compare a string and a number type, which you run the program all the time. Ultimately, we want to convert the string the program reads as input into a real number type so we can compare it numerically to the secret number. We do so by adding this line to the main body function. All right, mute guess, string new, that's all correct. Failed to read line, let guess, okay. So just make sure I get this all right. Let mutable guess, string new, that doesn't change. Read line, mutable guess, failed to read line, that doesn't change. But then we have this new thing here, and it's let guess U32 equals guess.trim.parse.expect. And let's type this over. Please type a number like that and like that. Ours, of course, breaks into the next line because I have my thing small for you guys to see. Why can't I scroll back over? Oh, here we go. I was grabbing the wrong thing. You guessed guess. And then this all stays the same from what I can see. So, yep, that's the only line that we add. Did I add my semicolon? Yep, I did. Let's go ahead and save that. We created a variable named guess, but wait, doesn't the program already have a variable named guess? Let mutable guess is right there. It does, but helpfully Rust allows us to shadow the previous value of guess with a new one. Too much talking, I'm getting thirsty. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables such as guess string and guess, for example. We'll cover this in more detail in Chapter 3, but for now, note that this feature is often used when you want to convert a value from one type to another type. We bind this new variable to the expression guess trim parse. The guess in the expression refers to the original guess variable that contained the input as string. The trim method on string instance will eliminate any white space at the beginning and end, which we must do to be able to compare the string to the U32, that makes sense, which can only contain numerical data. The user must press enter to satisfy read line and input their guess, which adds a new line character to the string. For example, if the user types 5 and presses enter, guess looks like 5 new line. The new line represents new line on Windows. Pressing enter results in a carriage return and a new line. The trim method eliminates that, resulting in just 5. The parse method on strings, which we have right there, converts a string to another type. Here we use it to convert from a string to a number. We need to tell Rust the exact number type we want by using let guess U32. The colon after guess tells Rust will annotate the variable's type. The colon after guess. Okay. Rust has a few built-in number types. The U32 seen here is an unsigned 32-bit integer. It's a good default choice for a small positive number. You'll learn about other number types in Chapter 3. Additionally, the U32 annotation in this example program and the comparison with secret number means Rust will infer that secret number should be U32 as well. So now the comparison will be between two values of the same type. Yes. The parse method will only work on characters that can logically be converted into numbers and so can easily cause errors. If, for example, the string contained a thumbs up, there would be no way to convert that to a number. Because it might fail, the parse method returns a result type, much as the readline method does, discussed earlier. We'll treat this result the same way by using the expect method again. If parse returns an error result variant because it couldn't create a number from the string, the expect call will crash the game and print the message we give it. If parse can successfully convert the string to a number, it will return the OK variant of result, and expect will return the number that we want from the OK value. All right, Let's save this. Let's go back to our terminal. Cargo run. Guessing game generated one warning. Could not compile guessing game due to previous error. One warning omitted. What was our error? Let's scroll back up to our code. Let guess. Oh, we forgot our semicolon. No, you guys probably caught that way before I did. So let's add that. Let's save it now. Let's go back here. Oh, okay. I still have a bunch of broken stuff, obviously. So our first error is here. Let mutable guess. While parsing the type for mutable guess, expected type. Expected one of. Okay, let mute guess. Oh, did I? Here, let's just open our code and compare it. We don't need a mute there. So let mute guess equals string new. I mean, there's my comment. That shouldn't affect anything. IOSTN, let guess. This is where we need to add our dots. Let guess U32, guess trim. Was there something else I missed? Unused imports on by default. So it's just saying we haven't used that yet, probably because my first error stopped it from working. So now if we save this, and now let's try it. Hey! So if we do 20, it should tell us too small. Okay. Now if we run it again, and 45 and we do 70, it should say we guessed too big. And if we run it again, we don't have anything in place to say you guessed. Oh, it says you win. Oh yeah, we did do that. Order if it equals, it says you win. Perfect. Let's scroll down. Nice. Even though spaces were added before the guess. So what happens if we do like, let's run a program and our input guess will be Tyler, 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 like that. The thread main panicked. It panicked. Please type a number. And it fails. Cause it to panic if you do that. Nice. Even though spaces were added before the guess, the program still figured out that the user guessed 76. Run the program a few times to verify the different behavior with different kinds of input. We did that. We have most of the game working now, but the user can make only one guess. Let's change that by adding a loop. Let's. Allowing multiple guesses with looping. The loop keyword creates an infinite loop. We'll add a loop to give users more chances at guessing the number. Okay? So we're adding this loop in. The secret number is secret number right there. And then we're adding a loop after that line. I see. So loop right there. Please enter your guess. And everything's going to be stored inside this loop, eh? So I'm going to have to work on my, whoops. So if we loop this in, I'm going to cheat and tab. I'm pretty sure there's a way to tab all this, but I don't know how to do it in Pluma or whatever this is. So if we tab all these over, because they're going to be stored inside of that loop variable. So now everything's in our loop variable is correct. As you can see, we moved everything from the guess input prompt onward into a loop. Be sure to indent the files inside the loop another 4 spaces each and run the program again. I don't think tabbing is going to break it, even though they said not to do that. Cargo run. Oh, see? Now we can do that. Oh, but it doesn't choose a new number yet, right? It still stays at 22. Well, which makes sense because we're just guessing the same number. But we probably, when we win, we want to go out of the loop. That's probably what they're going to talk about next. The user could always interrupt the program. Oh, wait, enters new program, it doesn't quit. The user could always interrupt the program by using Control-C, of course. But there's another way to escape this insatiable monster as mentioned in the parse discussion and comparing the guess to the secret number. If the user enters a non-number answer, the program will crash. We can take advantage of that to allow the user to quit as shown here. So you have to type quit. The thread main panicked. Yeah, okay, that works. We already made it panic when we wrote Tyler, Tyler, Tyler a bunch of times. Typing quit will quit the game, but as you notice, so will entering any other non-number input. This is suboptimal to say the least. We want the game to stop when the correct number is guessed. Yes, we do. I need a drink of water. Let's program the game to quit when the user wins by adding a break statement. Okay, so we're going to do match, and if it is equal to, so we're on this line right here. We'll do 1, 2, 3, 4. We can print line like that. You win like that, and then we'll break. Adding the break line after you win makes the program exit the loop when the user guesses a secret number correctly. Exiting the loop also means exiting the program because the loop is the last part of main. So let's go ahead and experiment with that. Cargo run. Oh, shoot. Expected one of... Print you win. Maybe they're going to correct it for us. Did I do anything wrong? Print line... You win break. Oh, I need to add, I see what I missed. So on, if it equals, I see. So we actually need to put this equals like that. And we're going to add some more curly cues, it looks like, because it's all stored inside of there. So we're going to add curly cues there. And we'll 1, 2, 3, 4. There. Print line. Well, we don't need it twice. Print line, you win, and then break. I wonder if that works. Hey, so now if we do like 20, it should say too small. And if we do 100, it should say too large. But if we do 96, it should say you win and then it exits the program. Perfect. Handling invalid input. To further refine the game's behavior, rather than crashing the program when the user inputs a non-number, let's make the game ignore a non-number so the user can continue guessing. We can do that by altering the line where guess is converted from a string to a U32 as shown in listing 2-5. Okay, so we are editing right here. Read line, immutable guess. That's all correct. Fail to read the line. Let guess U32 equal match guess trim parse. Okay. So we are changing this line right here. Right? So parse is the last part, and then we're adding curly brackets 1, 2, 3, 4. Okay for a number. So if it's a number, that means okay. That means go ahead. If it's a number. Otherwise, if it's an error, like that, it says continue. And then we need to add our curly bracket again, like that. So let parse, okay, number, num, error, continue. That looks correct to me. Let's see if that works. Shoot, I always screwed this up. What did I break? Expected one. So I broke it here. Let guess U32 equal. Oh, okay. I see what I broke. I see what I did wrong. So let guess U32 equal match guess.trim.parse. Okay, now, this is why it's so important to type it out, guys, and make mistakes as you go instead of copy and pasting, because you learn as you screw stuff up, as I'm doing right now. Okay, that works. So if we do that, it just lets me keep guessing, right? And if I do 60, we're good. Exits the program. Beautiful. We switch from an expect call for our cold backup. We switch from an expect call to a match call, which is what I updated. Expression to move from crashing on an error to handling the error. Remember that parse returns a result type, and result is an enum that has the variance OK and error. We're using a match expression here, as we did with the ordering result of the CMP method. If parse is able to successfully turn the string into a number, it will return an OK value that contains the resultant number. That OK value will match the first arm's pattern, and the match expression will just return the num value that parse produced and put inside the OK value. That number will end up right where we want it in the new guess variable we're creating. If parse is not able To turn the string into a number, it will return an error value that contains more information about the error. The error value does not match the OK num pattern in the first match arm, but it does match the error pattern in the second arm. Right there. The underscore is a catch-all value. In this example, we're saying we want to match all error values no matter what information they have inside them, so the program will execute the second arm's code continue, which tells the program to go to the next iteration of the loop and ask for another guess. So effectively, the program ignores all errors that parse might encounter. Now, everything in the program should work as expected, which we already did try it. Awesome. With one tiny final tweak, we will finish the guessing game. Recall that the program is still printing the secret number. That worked well for testing, but it ruins the game. Let's delete the print line that outputs the secret number. Listing 2-6 shows the final code. So let's do that. You know what we can do? Just in case we want to go back to it, we can comment it out. In case we need to go back to it for troubleshooting, we'll comment it out. And let's play our game and see if it works. Okay, what's our guess? Let's start with 50. You guess too small. Let's go up to 60. Too small. Whoops. 70. Too small. 80. Too big. Okay. So how about 75? 74. 73. 72. We won. It was 72. Very cool. There's our final code. Of course, we wrote it as we went along. At this point, we have successfully built the guessing game. We are 1 hour and 40 minutes into our journey of learning Rust, and we built our guessing game program. Congratulations if you hung out with me this whole time. It was good doing this. This program was a hands-on way to introduce you to many new Rust concepts: let, match, functions, the use of external crates, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership, a feature that makes Rust different from other languages. Chapter 5 discusses structs and method syntax, and Chapter 6 explains how enums work. Cyber Insight Candace said, thanks, Tyler. Great demo. Sorry for my newbie questions. Oh, man, no need to apologize. I am also a newbie. Especially when it comes to this. Thank you guys for hanging out with me. My voice is giving out. I mean, I've been talking for an hour and 40 minutes without a break. But we learned a lot. We wrote our first program. I'll be back on. I don't really have a set schedule right now. I was going to take a little bit of a break from streaming during the month of December, but I'll make this a regular series and we will continue to work our way through learning Rust. I may not cover this much stuff in each video because this is a lot to talk through, but hopefully you learned something. I know I did. Thank you guys for hanging out, and I will catch you guys in the next video. See you later.